To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, my dear children, in the earlier chapter, we discussed the properties related to the plane mirror images. Now, within this chapter also, you are given with a certain assignment here. Now, let's see what is this assignment. Stand in front of a large mirror which is on a dressing table or any other place. Observe the size and the lateral inversion of your image in the mirror. Think whether your observations agree with the characteristics of the images formed by the plane mirrors. And now what you have to do, you have to go and stand in front of a large plane mirror. And what you have to do? You have to check whether the previous characteristics are going to reappear on the mirror, my dear children. Okay, that means within the image created within the mirror, you have to recheck whether these things are going to occur, whether these properties are going to reappear or not. Actually, we can find these things without any trouble. Okay, so when you observe the image, my dear children, I think you have already got the experience of observing these images formed by the plane mirrors. So when you observe the image, my dear children, you can clearly see that these images are similar in size to you. There is no any difference. The image size is very similar to you. So we can come into a conclusion without any hesitation that the image size and the object size are equal to each other. There is no problem in it. The second one. When you go in front of a mirror and when you stand in front of a mirror, definitely, my dear children, the image which is created is also in the same direction as you, which you are as same direction of you. I mean, like the image is not inverted. Okay, image is not inverted. So without any trouble, we can say that upright images are getting created, right? The image is not upside down, no. The same way that you are standing, the image is also going to produce the same properties. So, my dear children, without any trouble, you can say that the images are upright. Images are upright. You won't be able to observe the distance between you and the mirror and the distance between image and the mirror. However, my dear children, you can do this thing. Observe like this. You go in front of a mirror and stand like this, then come to the front. Then observe what will happen to the image, whether it is coming to the front or not. Then go back like this. Then observe whether the image is also going backwards or not. By that way, we can come into a certain conclusion that, right, when changing the object distance, the image distance is also getting changed. So therefore, from that, we can come into a conclusion, right, that the object distance and the image distance are equal. Okay, then the next one, the lateral inversion. Sometimes when you are, like when there is a certain thing in your head, okay, when you have certain things in your, like when your head means your hairs, right? When you go and observe from the plane mirror, then when you are going to take it down, you won't be able to get the exact location by using the mirror. Sometimes when you are if boys, then sometimes when those guys are shaving down, right? Then sometimes if there are one or two hairs, then they won't be able to get the location for certain. It's because of that lateral inversion thing, my dear children. Because when we are moving like to a certain direction, the image is going to move to the opposite. So we won't be able to get the location precisely. Okay. I think some of you have this experience. If not, you can go to a plane mirror right now, and now check whether you can get a certain location, a precise location, by using your fingers and some kind of a thing in your hair. Check whether you can get it in the check whether you can get it in like in a like just by using one single chance, right? You won't be able to get it because of that lateral inversion thing. Okay, so the same properties can be observed in here also, my dear children. Try out whether you can do these things by standing near a plane mirror. Okay, right, so this is our assignment then. So like I said in the previous chapters, my dear children, it's very important to follow up these assignments. By that way only you can get the sound knowledge about the lesson parts. Okay, right then, so let's head on to see what are the other contents. Right, so here, my dear children, you are given with the next main topic. So within this main topic, we'll be mainly discussing about the users of plane mirrors. Okay, users of plane mirrors. So you know that plane mirrors are used in different kinds of occasions. Even you know that in our houses, in our like schools, in some different kinds of fashion designing places, in salons, as looking glasses, we use these plane mirrors. More often we use these plane mirrors as our looking glasses. Okay, so here let's see what are the users then, what are the other users. So first and foremost thing is given, like I said in the previous. So used in beauty salons and to wash one's own face, and in dressing activities also we use these plane mirrors as our looking glasses. Next one given, in shops to show the number of items increased. In shops, my dear children, we use different kinds of plane mirrors in order to get multiple images. So multiple images will enhance the look of certain shops and other stalls. Okay, especially in fruit stalls and in supermarkets, and especially in jewelry shops, we apply different kinds of plane mirrors. So these plane mirrors will enhance the look. Right, here the number can be increased. Okay, number of the objects can be increased. Actually, it's not getting increased, but the images created by the plane mirrors helps to show that the number helps to show a greater number. Okay, so that is why it is referred as the multiple images. I think in grade 7 you have studied when you keep two certain plane mirrors at a certain angle, we can get several kinds of, or else we can get several number of images, right? So when you keep it at a 90-degree angle, we can create like 3 images and so on, right? So those kinds of things, or else that kind of one is the one which is referred as the multiple images. Okay, multiple images. So we can get multiple images by placing 2 plane mirrors at certain angles. So when you increase the number of plane mirrors, we can also increase the number of images which is getting created. By that way, we can get an enhanced look for a certain fruit stall, supermarket, or else to a certain jewelry shop. Then the next one, to reflect light for laboratory activities. So can you remember, even we discussed this thing when we are discussing about the microscope thing. Okay, when we are observing from a microscope, we need to get light energy from outside, and also that light energy should pass through the specimen. So in order to do that, plane mirrors are being used to reflect a beam of light towards the specimen. Next one given, to produce multiple images. We already discussed that thing, my dear children, right? To get multiple images, I mean like in here, to show that the number of items increased, we use these things, plane mirrors. And also in order to get multiple images, the same thing, right? We can use plane mirrors. Next one, to observe the shape and the backside of costumes when selecting items. So when selecting items, my dear children, especially costumes, in order to check the front and back sides. I think in fashion houses, when you go for a dressing room, or else when you go to several dressing shops in order to buy textiles. So in that case, you have to get some dresses and you have to check the back side of it. In that case, you have to use these plane mirrors. Especially here, this thing is also related to that dressing things, right? Or else as looking glasses. Next one, in fashion activities. Simple, my dear children. In different fashion activities, we use plane mirrors. Next one, to observe backside of the head when one is having a haircut in a salon. So in salons, we discussed that thing. To get a hair, when you are getting a haircut, I think you have observed that the person who is giving the haircut is going to place a plane mirror behind you, and that reflection is once again reflected to the front mirror, and you can observe it very clearly. Okay, so when you are getting a haircut, you can check the back side of your head, okay, by using mirrors. So these are the uses of plane mirrors, my dear children, right? So most of the times we use these plane mirrors in order to get multiple images, and also we are using these things as, we are going to use these things as looking glasses, okay, and in laboratories for reflecting light. So my dear children, these are the uses of plane mirrors then. Okay, so as you can see, several figures are given here, right? So as looking glasses, see, here also looking glasses, and here also you can observe to get a clear image of your back side of the head. As you can see within the image now, you can clearly see the image of the back side of the head of this person. Then within this figure, you can observe there is only 1, 2, 3, 4, 5, right? There are 5 objects. However, as you can see within the figure, within the images, there are like several images, multiple images thing, right? Then my dear children, here also you can observe multiple images like this. So there are like several users, and over there in laboratory purposes, even we identified the properties of images by using these plane mirrors within our laboratory, my dear children, right? Within our laboratory, when we are doing several experiments, we did use these plane mirror images to reflect light. So in our laboratory experiments, we can use these plane mirrors. So in different cases like this, we can use plane mirrors, my dear children. Okay, so these are the users of plane mirrors then. Okay, right. Now let's head on to see the next content. Right. So next content is here also, this is also regarding the users of plane mirrors, my dear children, but especially in making several instruments, special instruments, we can use plane mirrors. So the first and foremost instrument is given for making the kaleidoscope. The kaleidoscope. So the kaleidoscope is going to produce vivid patterns when you insert a certain object into this particular prism kind thing. So this prism kind object is the one which is called as the kaleidoscope. Kaleidoscope. So what you have to do is, you have to take 3 plane mirrors, okay, which are in the shape of a rectangle, okay, 3 rectangular shaped plane mirrors, and you have to keep the shiny surface. Shiny surface means the reflective surface, right, like this. So this yellow color area is the darker surface, so the shiny surface is within the kaleidoscope like this. So you have to keep 3 of these together and create a prism like object, as you can see within the figure. Now what you have to do, you have to cover one end and insert some kind of a small object and observe through it like this. Then you can observe vivid patterns through the kaleidoscope like this. So various colorful patterns can be observed through this when small pieces of petals, leaves, or pieces of colorful papers are put into this. So what is the use of this thing? So these patterns can be used in fashion designing, in designing tiles and ceramic items, bathware items. These patterns can be used, my dear children. Okay. So kaleidoscope is important in designing things. When after observing these patterns, we can utilize these patterns in designing processes. Okay, right. So in making kaleidoscope, we can use this particular, or in making kaleidoscope, we can use plane mirrors, my dear children. Right. So this is the kaleidoscope now. So let's head on to the laboratory and we'll observe about the kaleidoscope. Okay. And we'll see how does the kaleidoscope is going to work over there. Right. Okay then. So let's head on to the laboratory and we'll observe the kaleidoscope, my dear children. So my dear children, this is the instrument which is called as the kaleidoscope. So you know that kaleidoscope is made by using 3 plane mirrors which is kept in a prismatic shape like this. So in order to hold the 3 plane mirrors, it's been wrapped around a cardboard sheet and been taped very well so that it will not fall. One side of the kaleidoscope is been covered. See, this area has been covered now. What you have to do is, now I have with me several rigiform balls, right, colored rigiform balls. So what I'm going to do is, I'm going to insert a single rigiform ball into this kaleidoscope. Then you have to, now you can see that within here there's an empty space, right? Within here there's an empty space. So what you have to do, you have to keep your one eye, and you have to observe the patterns. So if I'm going to observe it, it's like this. So like this, you have to observe. So you can insert like several 2 or 3 rigiform balls or any other material into this. Then you can observe, my dear children, like this. So when you observe, now I can see a vivid pattern created within the kaleidoscope. So these patterns are used in designing purposes mainly, my dear children, right? For the designing purposes of tiles, ceramics, and even in clothes also, these patterns are being used. Okay. So it's very simple. What you have to do, you just take the kaleidoscope and insert some objects and observe, right? Okay then. So once again, let's head out to the classroom and we'll observe the other things contained in the lesson. So my dear children, that's the kaleidoscope. Okay. Right. Not only the kaleidoscope, my dear children. In making periscopes, what is a periscope? Now this is the instrument which is called as the periscope. So periscopes are used in submarines, in bunkers, and in tanks, okay, battle tanks, in order to observe the environment, outer environment. We use these periscopes. So through an obstacle, we can observe the outside by using a periscope. Let's imagine that there is a wall, a certain wall. So if there is a certain wall, we won't be able to observe the things at the other side, no. So by inserting this periscope, we can observe the things which are at the outside of the wall. Okay. So through an obstacle, we can observe the things by using the periscope. Okay. So what you have to do is just place the periscope at the wall. Then you have to observe from the other end. Clearly, you can observe without any trouble what is going to happen with the other side. Okay. So let's see periscope. Periscopes are used to observe objects which are located above or below the position of the observer, to watch outside from a submarine or a bunker. So as you can see here, if a certain obstacle is there, right? So through the obstacle, you are going to watch it. So this is the obstacle. Now you are in here. So you won't be able to observe the other side because of the obstacle. However, if you keep the periscope like this, then you can observe the other side without any trouble. It's because that light rays which are coming from that side, that particular area, will come and hit on this plane mirror which is arranged, which is placed somewhat slanted, right, like this. Then will hit on this plane mirror, will travel downwards. Then another slanted plane mirror is placed over here at the 2 joints. So it will travel once again towards our eye. So all the things at the other side could be observed without any trouble through this obstacle when using periscope, my dear children. So periscope can be used like in here, see, within the water, right, within the water, in submarine, within the water, the people are there. Then through the water, the periscope is coming. Now over there, without any trouble, they can look what is the thing, what kind of things are going to happen within the outer environment. Okay, so periscope is very useful in submarines, in several ships, and also to observe from bunkers, right? The periscope, right, my dear children? So this is the periscope then. So to prepare periscope also, we can use plane mirrors. So now let's head on to the laboratory once again. Okay, let's head on to the laboratory once again, and we'll observe the periscope. Okay, there's a periscope which I have made by using cardboard and two plane mirrors. So let's head on to the laboratory and we'll observe that periscope, my dear children. So my dear children, this is the instrument called the periscope. So periscope is prepared by using now here this periscope is prepared by using a cardboard sheet. Now inside the periscope, my dear children, at the bends of these cardboard sheets, there are two plane mirrors, right? So in here also you can observe a plane mirror, right? In here, within this, right? I think you can see the reflection, right? See? And also in here at the other bend, right? So there are two plane mirrors at the two bends. So when a light ray is coming from this end, is going to travel towards the bend and getting reflected like this, and will hit on the second plane mirror and once again travel back to that direction. So by that way, the light ray is traveling to the sign of Z here. Okay, means that by avoiding a certain obstacle, we can observe the things or the objects which are located at the other side. So what you have to do here is, you just need to take the periscope and you just need to observe it like this, right? So when you observe it like this, you can see what are the things which are located at the other direction. So these periscopes are widely used in submarines, right? And also sometimes in ships also, right? So I'll show you how does the light rays are getting reflected within the periscope by using a demonstration with a laser beam. So I'll take a laser beam and I'll direct this thing from here. Now I'm directing from this end, my dear children. Observe, you can see on the other side very clearly. See? See, I hope that you can observe the light, the red color laser beam, right? It's mainly because the light rays are getting reflected. It's mainly because the light rays are getting reflected from here to here, then to over there. That's why you can observe the light without any trouble, even though I am directing it parallel to the ground, right, at a certain below level. However, it can be turned some kind to an upper level by using the periscope through the reflection of light rays. Right then, so this is the instrument called periscope, my dear children. So let's head on to the classroom and we'll observe what are the other contents in the lesson. So my dear children, that is the periscope. Okay, so I hope that you got the idea of the uses of plane mirrors. So my dear children, within this lesson part, we mainly focused about the uses of plane mirrors. Okay, we discussed several things, several uses of the plane mirrors then. Okay, now my dear children, we have finished the first and foremost main topic related to the lesson, reflection and refraction of waves. So we have finished the reflection of light waves. We have finished the reflection of light waves. So we discussed over there the properties of plane mirror images. First of all, we discussed about the reflection, right? What kind of a thing is reflection? Then we discussed about the laws of reflection. Then we discussed about images created by plane mirrors. Then we discussed about the properties of images created by plane mirrors by doing several activities. Then finally, over here we discussed the uses of plane mirrors. So we have finished the reflection part, the reflection of light, and now it's time to discuss about the second main type of wave which we are going to study within this lesson. So this is regarding, my dear children, the sound. Okay, sound. You know that sound is a type of energy, and sound is produced because of the vibrations. Sound is produced because of the vibrations, my dear children. In grade 8, we studied several things regarding to the sound lesson, right? Within there, we discussed that sound is produced because of vibrations. Vibrations are the speed movements of materials. Materials means it can be any kind of a liquid, solid, or else a gas, anything. If those things are getting vibrated, getting moved within a short time period at a heavy, several times, then that kind of a thing is the one which is referred as a vibration. Okay, so vibrations are the main reason for the creation of sound waves. Then the other thing is, my dear children, we discussed that sound is going to travel very fast through solids, then somewhat slower in liquids and very slow in gases. The sound is going to travel like 330 meters per second in normal dry air. However, like 2000 in water and like around 4000 within solids. Okay, meters per second. The speed is in meters per 1 second. 4000 meters per 1 second through solids. Through liquids, like around 1800 to 2000 meters per second. Then in normal dry air, it's around 330 meters per second. See, sound is going to propagate like in average those kinds of speeds within solids, liquids, and gases. Then, my dear children, we discussed that a medium is very important. Medium is very important for the propagation of sound. Medium means any kind of a material environment. Okay, material environment. That means it can be a gas, a liquid, a solid, anything. So sound is only passing from through these materials. I mean, like, you know that sound is a vibration, no? So vibration means a movement, right? So in order to create a movement, definitely there should be matter. Definitely there should be matter. Otherwise, there is nothing to move, no? If there is nothing to move, then, my dear children, sound will not propagate from one to another place. Okay? So to propagate sound, a material medium is very important. Material medium is very important. So I'm just giving out a brief on the things which we have studied in the previous lessons. Okay, so then after that, my dear children, in grade 9, in the same lesson, we studied about the musical instruments and the way of generating sounds and the sources of sounds and so on. Now this is grade 9. In this lesson part, we'll be discussing a special kind of a property of sound, my dear children, right? So let's head on to see what is that special kind of property. Right, so here it is given, be silent and listen to the environment for a moment. You may have observed sounds generated by the vibration of various objects. So like I said, because of the vibrations, sound is getting produced. So when you listen to the environment very carefully, you can observe different forms of sounds. All of these forms are getting created mainly because of the vibration of matter. Okay, mainly because of vibration of matter. Next point given, let us pay our attention to an important property of sound. Let us do an activity to identify it. So I haven't mentioned you the main topic still. Okay, now I'm about to. So that main topic which is given under the sound is the reflection of sound. That means, my dear children, like in the light waves, like what has happened to the light waves, sound is also going to do the same thing. What? Sound can also be reflected, my dear children. Sound can also be reflected. Okay, sound can also be reflected. That means when sound is going to struck on a certain object, on a certain surface, on a certain obstacle, what will happen? The sound waves are going to change its direction and going to travel to a different one. Okay, so this process is the one which is referred as the reflection of sound. So to identify about the reflection of sound, right, thoroughly, it's time to do an activity. So let's see what is this activity. So to do this activity, my dear children, we'll be needing these things. So here we are going to study about the reflection of sound. Let's see what are the materials you need. You'll be needing a stopwatch. A stopwatch, or else a simple watch is fine, no problem, right? Means that we need to only listen to the sound emitted by the stopwatch. Okay, then the next one, PVC tube. PVC tube, a simple tube will also do the trick, right? Simple tube made up with any kind of a material. It don't need to be PVC. Any kind of a material, in any kind of a tube which is made up with any kind of a different material. But however, within over here, I'm going to use PVC tube or any kind of a tube. Tube is okay, right? We'll be needing a tube. Then next one, a stand. Then a wooden sheet, or else a cardboard. Wooden sheet or else a cardboard, right? Then, my dear children, we'll be needing a reflective surface, like a tile surface or else a plain mirror, right? Right? Reflective surface means in here, now it's better to use a shiny one, but however, you can just, if there are no any reflective surfaces, then you can just go ahead with a certain, like a wooden sheet, a cleaned wooden sheet. That is also okay, no problem. Okay, but however, if it is reflective, then it is good. I mean, like from a reflective surface, the sound waves are not getting absorbed that much. It's getting reflected very well. So if you can use a tile surface or else a plain mirror surface, then that would be great. However, if you can't find, a cardboard or else a wooden sheet would also do the trick. Okay, right. So these are the materials that you need. So a stopwatch, PVC tube, a stand, wooden sheet or else a cardboard sheet, then a reflective surface like tile or else a mirror or else any kind of a cardboard or something like that. Okay, so these are the materials that you need, my dear children. Now let's head on to see the method. Right, place the metal or glass sheet vertically on the table. So that metal or the glass sheet, that's the reflective surface, okay? Metal sheet or the glass sheet, or else the plane mirror, or else the tile sheet, right? Whatever. So you have to keep it over there, right? Metal or the glass sheet, you have to keep it vertically on the table. Place the cardboard sheet perpendicular to it. Now that cardboard sheet, we have to keep it perpendicular, or else that wooden sheet. We have to keep it perpendicular as per to the diagram. You can see it very clearly. Fix the PVC tube to a stand as shown in the figure and place the stopwatch closer to one end of it. Now what do you have to do? You have to take the PVC tube and keep it over here. And you have to place the stopwatch near to that PVC tube, okay? From one side of the cardboard. Aim the other PVC tube. Now in here, you'll be needing two PVC tubes, my dear children. Okay? You can get the same PVC tube and cut into two different parts. Okay? Or else you can find out two different pieces of PVC. Right? Then what you have to do, aim the other PVC tube to the glass sheet from the other side of the cardboard sheet. Now from the other side of the cardboard sheet, you have to direct the PVC tube near to that hole over there. Okay. Next one. Adjust the position of the tube till a clear tick sound is heard through it. And now what you have to do? You have to adjust the position of the tube till a tick sound is going to heard. As you can see, there is an observer over here. Now you have to do what? You have to adjust the position of the PVC, like moving here and there, in order to hear a clear tick sound. Mark the position of the tubes on the table. Now remove the glass sheet and listen for the tick sound of the watch. Right. Actually, you don't need to mark these things, right? You know, like you can keep the PVC tube without any trouble, right? Or else you can, from your hand, you can, like keep the PVC tube, but you can hold the PVC tube without any trouble. Okay, right? So now in the next step, what do you have to do? Now you know that you can listen the tick sound very clearly. So after that, you have to remove the metal or the glass sheet or that reflective surface. Remove it. Now listen to the sound. What will happen? See. Now remove the glass sheet and listen for the tick sound of the watch. Repeat the activity, changing the position of the watch and using suitable sound sources instead of clock or the stopwatch. Right. So remove the reflective surface and observe. Then by changing the position of the clock and other PVC tubes, observe what is going to happen. Okay. Now, my dear children, let's head on to the laboratory. We'll prepare this setup and let's see what is going to happen over there. I'm the one who is going to conduct the activity, my dear children. Now, here the tick sound is very small, so you won't be able to listen it for sure. However, as I am the observer, I'm going to provide you with the necessary observations. Okay, right. Then let's head on to the laboratory. We'll continue with the experiment and we'll come back once again to the classroom to write down our observation and the conclusion. So my dear children, within this activity, we'll be investigating about the reflection of sound. You know that sound is a type of a wave, my dear children. Sound is created because of vibrations. So vibrations are types of waves which are traveling through a certain medium. So medium means actually it can be a kind of a liquid, solid, or else a gas. Now, when I'm speaking, you know that you can hear the sound. So you can hear the sound because these sound waves are transmitted to you guys through the air as waves. So these waves are referred as electromagnetic waves. We'll be studying about those things in our next grades. So up to now, we'll be investigating about how does the sound is going to travel through our normal environment atmosphere, right? In our normal environments, atmosphere. So you know that our atmosphere is filled up with air particles. So now within this activity, we'll be investigating about how does the reflection of sound is going to occur, right? So when doing this activity, I have prepared two setups of stands with a PVC pipe. Okay, so these two are PVC pipes, the two stands, and now here there is a stopwatch, and in order to fix a board, actually I have a board with me right now, so this is the board. Okay, I'll keep it over here, I'll take it when I'm going to need it. So to fix the board, I have two clay drops. Now let's set up the apparatus first, like this. First of all, we'll keep the stopwatch from here. Then you know that when I'm going to turn this thing on, I can hear the sound very clearly, right? Like this. The stopwatch is working, so I can hear the sound very well, right? Let's turn this into this direction. Now what I'm going to do is, I'm going to place, right, I'll take this one to over here so that I can keep the two PVC pipes like this. Okay. Now my dear children, I'm going to place the stopwatch from here like this. So as you can see here, when I'm turning the stopwatch on, the sound emitted by the stopwatch will come through the PVC pipe and will hit on the glass sheet over here, and it will reflect and come towards this pipe, and from this end we will be able to hear the sound of the stopwatch. However, you know that now when I'm facing the stopwatch, I can hear the sound still, because sound is going to travel through air and it can come to my ear without any trouble. So in that case, I will be using these two ducts of clay to fix a cardboard sheet, right, like this. Right, my dear children, now I can't hear any sound, right? So what I'm going to do is, I'm going to keep my ear from this PVC end, and I'm going to turn this thing here and there and check whether I can hear the sound clearly or not. Okay, right, now I can hear the sound. Right, now I can hear the sound from this end. Okay, now I can hear the sound from this end, because the sound which is coming from over there is going to hit on this particular glass sheet and going to come towards this direction, and that sound can be heard by me clearly because the sound is getting reflected when hitting on this glass sheet. Now what I'm going to do is, I'm going to remove the glass. Okay, let's remove the glass sheet and let's observe whether we can hear the sound once again or not. Right. Right, once again we won't be able to hear the sound because now we have removed the glass sheet. Once again, if you place it over here like this, now the sound can be clearly heard, my dear children, without any problem. It's because that sound is getting reflected when struck on an object, right? So that's why we can hear the sound without any trouble. So I'll once again remove these things, right? So now you know that by doing this activity, we can finally conclude that the sound is going to reflect when those things are going to hit on a certain object, right? Right. Okay, then let's head on to the classroom, my dear children. We'll write down our observation and conclusion from the activity. Right, my dear children. So our observations are quite simple. When removing the perpendicular cardboard, we won't be able to listen the sound. Okay, that means if I'm going to remove the cardboard, means the perpendicular cardboard means the reflective surface. I told you that we can use any kind of surface. So over there I use the glass one. So when I'm going to remove the glass surface, okay, I couldn't hear the sound. However, when the glass surface is there, I can hear the sound very well. Okay, so those are the two observations. When the perpendicular surface to the cardboard sheet is there, we can hear the sound very clearly without any trouble. When I'm going to remove that perpendicular surface, then I won't be able to hear the sound, my dear children. Okay, so what is the reason for it? Because the sound, the tick sound emitted by the stopwatch is going to travel through the PVC tube and going to hit on that reflective glass surface and going to come from the other PVC tube to our ears. Okay, that means, my dear children, here the final conclusion is the tick sound emitted by the stopwatch is getting reflected by the glass surface or else the reflective surface over there, right? So that is why we can hear the sound, my dear children. Okay, then that is why when I'm going to remove the glass surface or that reflective surface, I couldn't hear the sound. Okay, right, then we'll write down our observations. Sound is heard when there is a reflective surface. Sound is heard when there is a reflective surface. Then sound is not heard when reflective surface is removed. So when I'm going to remove the reflective surface, I couldn't hear the sound. Okay, however, if the reflective surface is there, then we can hear the sound without any trouble. So sound is heard when there is a reflective surface. Sound is not heard when reflective surface is removed. So what is the conclusion which we can take from this experiment? Conclusion is very simple, my dear children. What is the conclusion? Sound waves are reflected when struck on surfaces. So conclusion, sound waves are reflected when struck on surfaces. So sound waves are reflected when struck on surfaces. This is the conclusion that we can take from the activity. Based on what observations? Sound is heard when there is a reflective surface. Here, the glass sheet. So when there is a glass sheet, we can hear the sound. Sound is not heard when reflective surface is removed. Or here, when I'm going to remove the glass sheet, I won't be able to listen to the sound. It's mainly because that the sound waves are reflected when struck on surfaces. So the sound wave is going to travel like this and travel like that through the PVC tube after hitting on the surface, the reflective surface, same as the reflection of light. Okay, sound is also going to reflect. after hitting on a certain surface, any kind of a surface, right? So this is the observation. These are the two observations, and this is the conclusion that we can take based on the above observations. Right then, now let's head on to see what are the other things contained in with the lesson. So here, the reflection of sound. Okay, it is observed that the sound generated by the source was listened clearly at a certain point when the metal or glass sheet was there. So like I said, when the reflective surface is there, we can clearly listen to the sound. I could clearly listen to the sound without any trouble. The tick sound was given by the stopwatch, right? However, after removing the reflective surface, I won't be able to hear that tick sound given out by the stopwatch. So the second point, the sound could not be heard when the glass sheet was removed. Okay. The reason for this is the reflection of sound from the metal or glass sheet. So the reflection is the main reason for the occurrence of this observation. So my dear children, you are given with a highlighted point over here. What is that? Bouncing back of sound from an obstacle is known as the reflection of sound. Same as the reflection of light, my dear children. The bouncing back of sound waves when struck on an object is referred as the reflection of sound. The reflection of sound. So sound waves are going to hit on a certain object, hit on a certain surface, and going to travel to a certain other direction by changing its direction. Okay. So this procedure is the one which is referred as the bouncing back, or else the reflection of sound. Reflection of sound. So light and sound, both the things can be reflected. When these things are going to struck on a certain object, both of these waves are getting reflected, my dear children. Okay. So by doing the previous activity, we have proved that the sound also can be reflected. Okay. Sound also can be reflected. Right, my dear children. So this is what do you mean by the reflection of sound. So I hope that you got a good idea about the reflection of sound. Okay. So once again, what do you mean by the reflection of sound? The same thing which is going to happen for the light rays. Here, the sound waves are going to struck on a certain object and bounce back to a certain direction. So this is the one which is referred as the reflection of sound. Each and every object in our environment is going to reflect some amount of sound, my dear children. Some amount of sound is getting absorbed by the certain surface. Now, you know that sound means the vibrations, no? So, some amount of vibrations are getting absorbed by the surface, while the other vibrations are going to reflect to a certain direction. So, like in the same way where we observed in the properties of light, properties of reflection of light, some amount of light rays are getting absorbed to the surface while the other is getting reflected. Okay. The same thing can be observed for the sound as well. Okay. So there are different materials in our environment. Okay. So you are given with the next topic, my dear children. Not the next topic, next point over here. See. The obstacle that reflected sound in the activity was the metal or the glass sheet. Now, in the previous activity which we did, the reflective surface was the glass sheet. So, we use the glass sheet to reflect the sound. Okay. So, because of the reflection of sound, right, through the glass sheet, we can clearly listen to the sound. So that reflection process is the main thing, right? Behind the reflection of sound is the main thing behind the behind our observation. That's why we can hear the sound which is getting emitted by the clock. So my dear children, here once again given, sound is in the environment are constantly subjected to reflection by various obstacles. So like I said, my dear children, different objects are going to reflect sound to different ways. Okay. So within each and every object in our environment is going to reflect sound to different ways. Okay, so these sounds are getting reflected to here and there, right, by different objects that is in our environment. Different objects are going to reflect sound to different directions, right? So a specific property, this is a specific property that we can observe within the sound waves. Then here the final point given, most of the sound reflecting instances cannot be noticed, but there are some observable instances. Now, when you go to a cinema hall or else to an auditorium, I think when you are shouting over there, or when you listen a certain sound, you can hear a certain incident called echoing or else echo. The echo is created, my dear children, mainly because of the reflection of sound. Now, echo means when you create a certain sound, it's going to travel towards a certain obstacle and hit on that particular obstacle, then once again come to your ears. So that is what do you mean by the echo. So echo is created mainly because of the reflection of sound. When you go to top of a mountain, right, and when you shout, I think after like few seconds, you can hear the same voice of yours, which is coming from the other mountain, right? It's mainly because of the reflection of sound. When you are shouting, the sound waves generated is going to hit on that particular mountain or any other different obstacle and once again come towards you. So that is why you can hear your sound when you go to a top of a mountain and going to shout. Okay. So that's a phenomena which is going to occur mainly because of the reflection of sound. So my dear children, that the incident called echo is a great example to show the reflection of sound. Okay, reflection of sound. However, my dear children, we'll be not discussing about the echoing process. We'll be discussing about the echoing process, but however not in this chapter. Within our next chapter, my dear children, I'm going to talk several things related to the echo, and also when a certain echo is going to happen, there are certain other things or other effects which is going to happen mainly because of the echo and also the reflection of sounds. So we'll be discussing about further things related to the reflection of sound and about the echo, and also there's another thing which is called as the reverberation. All of these things, right? But however, not within this chapter, my dear children. We'll be discussing these things in our next chapter. So I'll be planning to meet with you with our next chapter to discuss the further things related to the reflection of sound.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.